Hello guys, welcome to MoBileMaThS with Gamchirai. Today we want to look at joint variation. I've got an example here where I've got the mass M of a coin of radius R and thickness T. Let me use H here instead of T. Depends on the volume V of the metal in the coin. So we can have M varies directly with V. In the V of a coin, this is our coin. Okay, so it has got a radius R and an H height there. So the volume of the coin becomes pi R squared H, like that. So I can substitute into this variation and have M varies directly with pi R squared H. And my pi in this case, my pi is a constant. This is a constant. So I can ignore it and have M varies directly with R squared H. So this is the variation that we'll have. And what it means is that the mass of the coin varies jointly with the square of the radius and the thickness of the coin. That's what we have written there at the end of the day. This is what we have. Okay, so I'm going to have 3 examples of joint variation. Let's look at the first example. So the first example, I've got P varying inversely, jointly with Q and inversely with R squared there. So we want to find the equation that is connecting our P, Q, and our R. So what we do, we write our P varies jointly with Q over R squared, that's inverse with square. So we introduce our constant P is equal to K. I can have my Q R squared like this. Okay, now I'm going to use the information that I'm given. QP is that, Q is that, and our R is that. Let's substitute into our equation. We will have, at the end of the day, if we substitute into our equation, our P is 3.5 is equal to 3.1/3, sorry, is equal to K. Q is 5 over R is 3 squared. Okay, like that. Let's simplify. I would like to write this value there of P in terms of an improper fraction. I'll have times and plus here. So I'll have 10 over 3 is equal to K 5. 3 squared is 9, like this. So to get my K, I'm going to multiply both sides by 9 over 5. By 9 over 5. So I want to cancel 9 and 9, 5 and 5. That's why I have 9 over 5. Let's do that. So on the left side, on the right side, I'll end up having a K. Then on my left side, I'll have 5 into 5, 1, 5 into 10, 2, 3 into 3, 1, 3 into 3, 3. So I have 3 times, then I get a 6. So the value of K there is 6. And if we are to write, the relationship becomes P is equal to 6 by Q over R squared. So this is the relationship. Okay, that's the relationship there. Okay, now we are going to use that relationship to find the unknown values. Okay, so the first question is find the value of P when we are given that. So let's find P when we are given that information. P is equal to 6 by our Q is 5. Our Q is 9, sorry. Our Q is now 9. Let me check. Our Q is now 9 and our R is 1,2. Okay, fine. So we have got Q9 over 1,2 squared. Okay, like this. So this we can simplify easily. Let's simplify. I've got P is equal to 6 by 9 over 1.2 squared. I get 1.44. 1.44 into 9 and multiply by 6, then I get my P is 37.5. That's the P value. Okay, let's go to the next question. Okay, the next question, I've got this one. They want us to we are given P is that and V is that. Then they want us to show that how P and R vary with each other. So what we do is this. We can take, let's take the second equation. We have v varies with r squared. Let's introduce a constant. We'll get v is equal to k r squared. Okay, so I can now substitute this into the first equation. I want to substitute this into the first equation that I was given, this one. I want to substitute onto this v. Okay, so let me substitute. If I substitute, I will get, we had our p, or I'll get p varies with 1 over k r squared. Okay, like that. That is what I'll get at the end of the day, because remember, this is my v. This is my v here. This is the value of v. Okay, now with that information, I can now simplify. Okay, if I simplify, I'll get p varies with 1 over k by 1 over r squared. Okay, like this. This is the same thing. I've just rewritten it like that. So if I take 1 over k, 1 over k, this is a constant here. This is a constant. Okay, this is a constant, so I can take it away and remain with p varies with 1 over r squared. Okay, so at the end of the day, this is how they vary with each other. You can even do with the substitution of where you can make v the subject of formula on the other equation. Okay, you will still get the same thing. Let's move on to the next question. Okay, so the last question, okay, this one is a little bit tricky, but very similar to the previous question. So we have got if x varies with yz to the power of a third and y varies with z to the power squared, show that this is that. So, and we are also given an extra information if y varies with z to the power of minus 2, that one. Okay, so let's use that information. What we can do, we can write y is equal to, I'm taking this one, y is equal to, introducing a constant, I've got k over z squared. So this is the same thing as z to the power of minus 2 is equals to 1 over z squared. Okay, that's where I'm taking this from indices. Okay, let's go on. With that information, I can now make z the subject of formula. I want to make z the subject of formula. So I'm going to multiply both sides by z. I'll have z squared y is equals to k divided by y. Then I'll get my z squared is equal to k over y, like that. Because this left side, they cancel off each other. Okay, now on the left side, I've got a squared there. So to remove that, I'll find the square root of. Okay, then I'll get my z is equal to that. Okay, so my z becomes square root of k over y. That's how I get my z. So I'm going to substitute this z into the initial equation that we were given. Okay, we were given that, let me write that down. We were given that x varies with y. Let me write that down. We're given that x varies with y, z to the power of 1/3, like that. So this is what I want to substitute our z there. I'm going to substitute the z that we got here there. Okay, let's substitute. Then I'll have my x varies with y. My z becomes k over y. Remember, square root is to the power of 1/2 there. Then I've got that's 1/3 there. Let me put it in different color, to the power of a third. Okay, like that. So if we have something like this, what it simply means is you can simply multiply these two powers there and get your solution. Okay, so now multiplying those two, what do I get? I will get x varies with y and k over y to the power of 1 over 2 times 1 over 3. I'll get 1 over 6. Okay, now I've got this 1 over 6. Let's simplify. So with this 1 over 6, I can rewrite this whole equation in the form separating k, our constant. I want to separate our constant, this k there. Let's do that. So I'll have x varies with y. Then I've got k to the power of 1 over 6 over y to the power of 1 over 6. So that's what I'm doing to separate these two. Now, with that information, now I can take away my k. Let's see. Okay, before I take away my k, I can simplify the values of y there. These two y's there. I can have my x. I can have my x varies with y. The first one is to the power of 6 over 6. And because it's dividing that one, we can subtract the powers 1 over 6. Then we have got our k to the power of 1 over 6. Okay, then I have x varies with y to the power of 5 over 6. And k to the power of 1 over 6, like that. Now, because our k is a constant, we can remove this one. Okay, then if we remove that one, we will remain with x varies with y to the power of 5 over 6. Okay, so this is what we wanted to show, so that's shown there. Okay, otherwise thank you guys. Let's meet in variation 5, where we'll be looking at partial variation.